HPLC method development is the topic for the video, and let's start with the video with some introduction. HPLC method development starts with the objective. First we need to have the clear objective whether we are developing the method for API or it is for related substances, and based on that the method development will go ahead. So what is the aim and objective of the method development? What type of analysis will be done, like assay, related substances, and stability testing? So first it start with the column, selection of the column, that is called as HPLC column, and column can be of different types, but in starting the C18 column can be used. So method development can be started with using C18 reverse phase column, and if needed other columns can be tried like C8, phenyl, CN and HILIC or helic columns. The column affects the retention time, the peak shape and the resolution. The separation takes place in the column. That's why column selection is an important step in the HPLC method development. Once you select the column as a trial, and then you can go with the selection of the mobile phase. Common mobile phase combinations are water plus acetonitrile, that is called as ACN, then water plus methanol, and other combinations can be tried with organic and aqueous phases in different concentrations. Use buffers like phosphate or acetate to control the pH and adjust the pH based on the analyte's pK. This is for the mobile phase selection. Then set the detection wavelength. Whether you are using the UV as a detector or it is a PDA or DAD. So use the specific detection wavelength. Use UV visible or PDA or DAD scanning. Find the lambda max. The lambda max is the intensity at which the maximum absorption takes place. It is called as maximum absorbance. Common range of the lambda max is like 210 to 280 nanometer. Correct wavelength is required to be selected. So correct wavelength improves the sensitivity. Then go for the optimization of flow rate. Generally flow rate starts with 1 ml per minute and it is adjusted based on the back pressure, peak resolution, peak shape of the analyte. So there should be a balance between speed and the separation quality. Then select the injection volume. Choose the right injection volume. Generalized volume range is 5 to 20 microliter. Large volume can lead to peak broadening. So use the smaller volumes for narrow pore columns and keep volume consistent for the better reproducibility. There are different types of gradients like isocratic gradient is there and another is the simple gradient. So select the illusion mode, whether it is isocratic or gradient. So it is a illusion mode. Isocratic is provide you the constant mobile phase. It is simple and reproducible and best for the simple mixtures. But gradient can give you changing mobile phase composition and better for the complex samples. Generally, the method starts with the isocratic and it can be switched to gradient illusion mode if required. Then final optimization is for the fine tuning of the selected parameters. The parameters are required to be adjusted for the best performance. Fine tuning of the pH, buffer strength, flow rate, column temperature is required with the aim for getting the sharp peaks, clear separation of the analyte. Perform the SST test, that is system suitability test, to check the method performance. So it is done before analyzing the samples. Resolution should be more than or equal to 2. Tailing factor less than 2. Theoretical plates numbers should be more than 2000 and RSD should be less than 2%. It ensures method is working properly. Robustness and repeatability testing. So make it reliable. Test with small changes in pH, flow rate, temperature, and check the results with the optimized parameters, or compare the results with the optimized parameters. Results should be consistent so that you can say that the method is robust and it is reproducible, though there are some changes or small changes in the pH, flow rate, and the temperature. Then comes to the documentation. Document all the things performed, column and mobile phase details, method changes, validation results, what type of troubleshooting was done. So troubleshooting steps are required to be documented clearly. Then it helps in audits and method transfers. Whenever you have a problem, then write down it and how you solved it. It should be written so that whenever you are transferring the method, this will help you. Validate and implement and follow the ICH guidelines. Validate the method for accuracy, precision, linearity, LOD and LOQ. Then apply in the QC analysis. So successful method development start with the goal, choosing the right tools like column, mobile phase, flow rate, injection volume, then optimization of the parameters, and then fine tuning of the parameters, validating the parameters. This is the simple way for HPLC method development, and in upcoming videos I will be making the detailed informative videos on each and every parameter for the HPLC method development. Thank you for watching the video.